Okay, I'm recording again. Now, so for example, I got logged out, right? You don't need to log in. You can keep the same terminal for you. So you can close your computer. Everything is still the same. So the next day you want to continue to work, you don't have to do anything. Okay. So I start my, you can see my terminal, right?
Yeah.
Okay. But before that, actually, I want you to close SWB. All of you close it one more time. Close it. And actually, I want to set a terminal. So for all the project you are going to work on SWB, they save under a directory. So try to make a directory. Let me call it mkdir is the command to make a directory. And then give it a name, space. For example, let's call it stdb1 for me, right? It's up to you. I make a directory called stdb1. Can you see it? Can you follow what I'm doing?
Yeah.
Just make a directory.
Yeah.
Okay. If it is done, then I'm going to set a variable so that it will point to this directory. Okay. SETENV, set environment, right? And then I type stdb. This is a variable, environment variable. It's saying that, okay, go to this directory in the future whenever I open SWB. So I'm going to put the full path. For me, this is my ID. For you, you have /home, your ID, / and then stdb1. Like this. Can you do that?
Okay, one sec. So actually my computer, my remote computer just has a blue screen. Do you want me to wait or reconnect?
Okay, you press the space and then it will ask you for password.
Oh, okay, okay.
Yeah, it log out, it log your screen.
Yeah, I was just trying to click on the screen and see what happens, but yeah, I'm back in. So let me just, you wanted me to close SWB, right?
Yeah, close it, yeah.
Okay, and then make our own directory.
Yes. mkdir space, and then give a name. Let's say call it capital STDB1.
Okay.
And then point to it. Set SETENV, right? Set a variable.
Is this directory going to be for all the projects that we do?
Yes.
Okay.
So when you're done, let me know.
Okay. And it's going to be our student ID, right?
Yes, because that is your folder. By the way, you can type PWD to see where you are. When I type PWD, I know I'm under this folder.
Oh, okay, okay. PWD. One sec, almost done. Okay, I did that.
Okay. Tuyen, are you able to do that?
Yeah, I got it.
You got it? Good. Okay, then let's go back. I use this again, right? Go back arrow key, SWB release, and then I start it. Okay, then the window pop up. Does it work for both of you? You all get the window comes out?
Yeah.
Okay, good. Okay, so Tuyen, you are okay, right?
Yeah.
Okay, I'm not going to ask you again. If you have problem, please stop me, both of you, okay?
Okay.
Now, then I go to So this is the SW. Remember here, I just created this directory stdb1, right? Because I told it that you can go to this direct SWB, that this is where I put my project. But at the same time, on the left, it also show me other project which is come with the installation. They have all the example. For example, CMOS, FinFET, power device, whatever. They are all here, right? Here's a good example we are going to use, okay? Now, so let me go to help. If you go to help, you see a training, right? I click on training. Then a Firefox should pop up like this. This is a self-paced training. Usually I just ask my student to go over this, and indeed in my email, I also tell you that if you're interested, you can go over some of them. These are very extensive. We don't have time for all of this, and you are not going to use all of them in those in the near future, right? Because this can take the whole PhD to learn, right? But we will only learn some of the basic thing, right? But because you are new to TCAD, I will go over the tool overview with you quickly. So what is TCAD? Right. So basically, TCAD is a tool to solve differential equation. For example, this is a transistor. All the transistor from fabrication, how do you make a transistor? Like what Tuyen said, she went to David Parent's lab. You do implantation, you do annealing. Those are all physics behind. Either you have physics to tell you under what temperature, how the silicon will diffuse. The physics tell you that under what energy the ion will penetrate into the wafer. And then you form something called junction. And E128, you learn that you have a let's say PN junction. How do you form that? You actually do that by introduce some impurity, for example, boron or phosphorus into it. But you need to control it. How much you want to introduce? 1E18, 1E19, and how deep you want to introduce. And how do you do that? You use ion implantation or diffusion. And all this, they rely on physics. We all know what energy, there's an equation governing how this particle would diffuse or penetrate. So we can solve differential equation. So TCAD, the first thing is can do process simulation. For example, maybe not here. The first thing is process simulation. It simulate, you tell it what energy you're using, what temperature you're using, and what mass you're using, then you get the transistor. The second thing is how it behaves. If I apply a voltage to it, you know PN diode. Apply a forward bias, it has a large current. Apply a reverse bias, it has small current. Then we all know the theory. We can solve the equation, and then we can determine their current. And that is the second thing TCAD can do. For example, here we simulate the Poisson equation, how the electron transport and how the electron distributes. Then we know how the current will flow in the device. And that is the most variable thing about TCAD. In reality, you cannot cut a device and see how the current flow, right? But you only can measure the terminal. But in TCAD, you can look at individual point, find out what is the electric field there, why the current is so low, and to understand your device, right? And that's why I said in real lab, you can only get this curve. So it depends on how good you are and whether you are interested. By the end of this year, I'm going to have a probe station at cryogenic temperature that you can use to measure the IV curve of transistor. And that is one of the research I'm doing. So this is not just for TCAD, right? If you really get interested in this, I really hope that you are very interested in this and you enjoy doing experiment and also enjoy doing theory, right? And that you will learn a lot for this, right? I can claim that my workstation will be the lowest temperature in San Jose State U at this moment, right? When it's arrived, because that is the lowest temperature we can go to at about 4.2 Kelvin, liquid helium, okay? So that's what TCAD doing, right? It predict what happened, how you build a structure, it measure the current, right? But how do we do the simulation? So we have simulator. One is called Sentaurus process, S process. It simulates all the process flow, ion implantation, diffusion, etc. Give you the final profile. Another is Sentaurus device, S device here. S device is used to simulate the electrical behavior. There's no limitation. You just imagine any novel device. You want to invent something, you just think about it, and then you ask it to simulate. It solve all the physical equation and tell you whether it behaves as what you want or not. Okay, these are the simulator, right? But however, sometimes we don't know the process. I don't know how to make it. I only know that if I can create a structure like this, now you draw a picture in your exam paper, right? Or to your boss, but you don't know how to make it yet. You just say that I need to have silicon at this place, this doping, and this width, and I think it will give us a great device. That is an idea, but you don't know how to make it. You can use something called Sentaurus the structure editor. You just describe it saying that I have a doping profile here, I have a box here, etc. Okay. So these are the three main simulation tools, right? One is process simulation, one is device simulation, one is structure creation purely geometrically, no physics there. But to make it, to increase the productivity, we also have something called Sentaurus Workbench. That is the program we just started. It's just like a workbench in your lab. In your lab, you have workbench, you put your ammeter, voltmeter, you do measurement. So the workbench facilitates your simulation. So today mostly we work on workbench. I'm going to tell you how to create different splits, how to do it very quickly so that you can do a lot of different simulation. Okay. Any questions so far?
No, not yet.
Okay, good. So this is called TCAD, right? So I probably don't want to go to detail, but here we can take a look at this figure, right? You can do implantation, do the spacer, string implantation, and then full structure. That is process simulation, right? And then for device simulation, you can do a lot, right? This is the structure editor. You can create 3D device, right? For device, you can see at different second, right? How the current is flowing, etc. Okay. So I won't go into detail. I would like you to, and okay, one more thing I forgot to say is you want to inspect the result. How do you inspect the result? You use something called Sentaurus Visual. Where's that? Here. This is another tool we need to learn, that you can cut the device, look at the distribution, and you also can plot the IV curve. So after all, in TCAD simulation, imagine you are in the lab. It's just that it's risk-free. You are not going to break anything. You can apply 1 trillion volt. The worst case is it just tell you that it does not converge. It won't break the building. It won't get you on fire or whatever. So you can really be very free to try whatever you want. Okay. So this is the basic introduction. So with this, right, go back to take a look if you're interested. Then we go to the Sentaurus Workbench, right? So usually I will ask students to read themselves, and you see that it's not too difficult, right? But however, I'm going to just do hands-on training with you, right? Usually you only need to read 1 to 4, right? So let's go back to the Sentaurus Workbench. You already opened it, right? So I already told you on the left, you put the project, on the right is the table, right? So here we have the application. Can you go to getting started? And again, this is just like window. In window, you want to do something to an object, right? You right click your key, right? And then a menu pop up. And then you choose whether you copy and paste or run or whatever. Pretty similar here, okay? So can you expand the folder, go to getting started, and then let's go to the S device, okay? And then choose SOI IDVG. Now, if I double click it, you see it give me this, expand it. And then on the top, it tell me the path that I'm in. This is the full path. So can you double click and let me know if you are at this stage?
Yeah, let me try it in a second.
How about this? When you are done, just put the either let me know or just put a thumbs up in the chat box or in the participants list.
Wait, which device is it? Under S device?
Under getting started, S device, and then SOI.
Okay.
Sorry, I cannot hear. Can you say again?
Is there a way to like zoom in on it?
To zoom in?
Oh, yeah. Hold on.
Yeah.
I think I see it.
It's too small for you?
Oh, yeah, I got it. I got it.
Okay. Maybe Control Plus. So sorry, Tuyen, are you okay?
Yeah, I got it.
You got it, good. Now let's copy this one. If you try to run it here, it won't work because this is not under your directory. It's a public directory and you don't have the right permission. Linux is like this, also similar to Windows. This is an area you cannot touch it because you are not the super user. Okay, so let's copy it. What you can do, right click. You see you have many options, right? You can explore them. One of them is copy. Click on copy. And then now go back to your home directory. In my case, it's here. I right click and then I say paste. Now I expand my folder. Then I double click. I got SOI ID VG. Is that okay? In particular, on the top, when I double click it, you see this folder that is changed to my path. It's no longer the old one, SOIID, the old one. If I double click on this one, you see it is a path to the installation directory. If I click on mine, it is in my directory.
When I did it, it said permission denied, I think.
Right, so you need to right click here and then copy. Have you done that? Paste it.
I'm copying and then I'm pasting. I'm pasting it to my home directory.
But
when I paste it, it says creation of directory permission denied.
That is strange. Okay. Can you share your screen?
Yeah. Can you see my screen?
Still waiting. Are you sharing?
Now I am.
Okay.
Can you see?
Yes, but is this your directory? Okay. See, you did not. You are trying to put in
Oh, and someone else's
your
directory.
username. Yeah, I think you are copying mine. You try to go into my directory.
Yes. Should I exit?
Yeah,
SW?
exit. Yeah. Right. So use the arrow key to set the STDB one more time. Just arrow key. Maybe you just do can you maybe Control C? Do a Control C to clean up. Control C. Yeah, and then do it again. Go up.
This one.
Keep going. STDB one, maybe the next one. Go down. Right. So
I thought you wanted me to
no, go down. One more. No, this one, yeah. The variable, no need to delete, use arrow key. Go to the second, it's not TCAD research, it has to be STDB.
Okay.
Use your arrow key, left key, no. Oh, yeah, left key, yeah. Keep going. Yeah, delete this one to STDB. It has to be capital STDB. You have an extra H. Try to go to left and then delete it. Move your arrow key and then delete. Yeah, and then enter. Start one more time.
Okay. This way?
Yes.
Okay.
Now try to copy one more time.
Yeah.
Your resolution is very big. Tuyen, you also have this big resolution?
I think I have the same problem at him. So it doesn't show it's on my, it's under your ID.
Yeah, it should not be under my ID. Right? I told you, remember, you just do everything the same, but change to your ID.
Okay, I'm here now.
Okay, I see that. Tuyen, you want to share or you're okay?
Yeah, I can share.
Yeah.
Okay, so.
Okay, it's good now. Yeah. So then maybe close. Can you close the SWB and start one more time?
No, this one?
Yeah. And start SWB one more time. You can use arrow key. Just use the up arrow to go back to the command. Yeah. Right. Now, can you copy from getting started? And then S device. Yeah. And then SOI IDVG, double click. Okay, copy is okay, good. And then go back, yeah. Right click. Okay, now, yeah, good.
Yeah.
And double click. Make sure that you are in that working directory by double click. Okay, very good. Oh my God, that might be some very slow. So Tuyen, you might run into an issue, or both of you. Somehow this remote desktop has some issue. So if you see that it's loading so slow, try to go back to your Windows. Just copy a text, any text, ABC, a text. Then that should solve the problem. Okay. Just do a Control-C. No need to do anything. Just flush the buffer.
Okay.
Okay. But you are okay, Shubaka. But
Yeah,
at the end, I see you keep rotating. You might have this problem. Okay. So now I go back. Okay. So what is a project? You see that I have 3 icons here. Each icon represents a simulation tool. Remember? Do you remember what is SDE? Anyone remember?
Yeah, it's the structural thing.
Structure creation. Wonderful, right? How about S device?
You can make different, you can simulate electrical properties.
Yes. Yeah, very good. And then SVisual?
Allows you to look at, I think, the flow of, it allows you to visualize everything.
Visualize, yes, yeah. So you see I have 3 tools, right? Remember I told you SWB is just a workbench. It does not do any simulation. It helps you to organize. Okay, so I have 3 tools. For example, let's say if I want to add a tool, what do? I right click this one, right? Let's play with that. Right click, and then you say add. Okay. And then you can choose the tool. For example, I want to create a new structure. I just click on S process, right? And then I have this S process. You can say you add it after this tool or before this tool. For example, I say after this tool, then I get S process. I can type Control S to save it, right? This is just a demo, but I don't want it. So how do I remove? Just click on it, left, and then left click. And then I just say delete. Then you will be gone. And Control S to save the project. Is that okay?
Yeah.
Good. Now, so with this, then that's cool, right? But how does it know what to do? You need to give it a command, right? Because they are all simulated, they're all programmed. So for each tool, there is a file, at least one file associated with it, called the master file. If you right-click the tool, you see that it has something called edit input. And you just click on these commands. And you see this one pop up. This is a lot of command. This is the difficulty about doing TCAD. You actually need to learn many different, you can treat this as a programming language. But however, the good thing is that it also has some GUI window. You can use it tomorrow or maybe today if we have time. I will tell you how to get this command by just drawing on a GUI interface for SDE. But no matter what, it has a master file associated with it. Okay, this is the so-called master file, right? If you can use Control Tab if you want to go back, right? Same for S device. Right click, add the input, commands. Click on this. And this is another set of command. Now here I can explain a little bit. It tells you what are the electrodes, right? Files. What physics I want to include, right? And then how I want to ram it. I will change the drain voltage to VD, for example. Okay. Even if you go to the SVisual, it also has a command. This do automatic extraction, right? Do not get scared by this. Eventually, you will know this and you can modify from template. But that is the idea. Okay, so, but there's one thing very interesting. How about all this variable here? We call it parameter. So this parameter is this. If you try to open S device, right click, edit commands, you do find some variable, looks like correlating to this one. For example, VD. I have a VD here. Right? Or let's only look at VD because I can only see it here, right? So what does it mean? So SWB has something called parameter or variable. It has two types. One is built-in, and other is user-defined. These are the user-defined variable. When it see at, something at, then you know that this is a variable. It's going to search, it find that, oh, you have defined something called VD. It's going to substitute the whole thing by 0.05 and then send this file to S device to run simulation. Make sense? Probably you don't know what I'm talking about yet, right?
Yeah.
Let's, yes, you understand or you don't know?
Yeah, I understand. Yeah.
Great. Let's do something. The process of substitution is called pre-processing. So for every SWB, you need to pre-process the master file and then before you run it. Okay, so you right-click. No, right-click the project. Go to project. Instead of run, You can do it at the same time, but I want to show you, let's just do pre-process. I click pre-process. Then a window pop up, right? At the particularly, I want to show you this. I search through the log file. Do you see this one is what it say? Parameter substitution, VD replaced by 1.5. That is for a particular node. Now, if I go back to this project, I press F9. Can you press F9? Then you see the node number. Each cell is associated with a node. This is very important. It helps you to navigate. For example, this cell, let me go back, right? Look at this pre-process process. It say in this directory, this is my directory, right? This project, right? It say, what should I do? What should I, that's not what I try to show you, right? Let's go to here. In the node 14, N14, it say the VD is replaced by 1.4 because 1.5, because I put 1.5 as the variable for VD for 14 for this row. Okay, so you say, well, how come? Isn't that you're talking about 14? Yes, but 8 is not a real node. This is just a tree. Each of them is an experimental split. It said experiment 1, okay, same, create a structure, but then I want to have body type, and then the VD is 0.05, avalanche factor is 1. Experiment 2, everything is the same, except VD becomes 1.5, avalanche factor is 1. Experiment 3, everything is the same, but avalanche factor becomes 1.5. Experiment 5, 4, everything the same, but now it is floating instead of this one. Okay, so pre-processing is to do substitution. Now, for example, can you double click node 14? Then something called Node Explorer will pop up. It will collect all the files related to node 14. If I click on this one, PP14, this is the command file. It's going to send to S device to run simulation. Let's compare this one and the master file. Remember, I keep emphasizing master file. Master file is the one you supply to SWB. And then SWB does the pre-processing. Let's only look at the solve session. You see that they are the same. Solve, new file prefix, init, right? They are all the same until here. Go drain. In the master file, I say add VD. Now it becomes voltage equal to 1.5. It does the substitution. Okay. That is 14. If you don't trust me, let's click at 12. This time, what would it do? I look at the CMD file. Everything is the same, but now the drain becomes voltage 0.05. So do you see that? For you only need to put at VD at, and then you build this table. You can run a bunch of simulation. Imagine you have different measurement. You want to do measure to 1 volt, 2 volt, 3 volt, 100 volt. You just do this in a table, but you still use the same master file. SW will substitute for you and then send to SDWise and run 100 different simulations.
Okay,
is this
so
okay? Mm-hmm.
So is this how you come up with the characteristic, like IV characteristics?
There are a few things, right? So for IV characteristic, for example, you ram the IDVG. You change the gate voltage and try to see what is the drain current, right?
Yeah.
But you can have different drain bias.
Yeah.
Drain can be at 0.1 volt, 10 volt, 100 volt, right? So here I get the characteristic. I do get it by ramping the gate voltage to 1.5, but in order to get that for different VD, I need to have a split here, either 0.05 or 1.
Yeah, but through this you can run a bunch of you can have like a tree of experiments, and then from the results you can come up with the characteristic.
Right.
Okay.
Okay, we can see more later. Yeah, good. So that is the user-defined variable, right? Let's play with it a little bit. How about that? How do I add a new variable? I right-click and then just say add parameter value, right? Let's call it my VAR. Is case sensitive, okay? So make sure that you use the right case. You don't have to follow mine, but you need to use the right case, right? Let me just call this, let's say 1, if I put 1, okay? And maybe give one more value, 0. What will happen? You see that it automatically will do 0, 1, 0, 1 for all the split. So it just blow up the experimental tree. Is this okay? But if I run it, it's not going to have any effect because I did not call it in my master file. Okay, so first of all, are you able to add a new variable?
Let me do that one sec. I was just paying attention to what you were doing. So
Good. Yeah. So I think we should do this. Yeah.
Okay, one sec.
So it's like
Yeah.
white out.
Okay, this is just coloring. I think we just I don't know how to solve it. In some system, it had this problem. It's just the icon doesn't look good, but you know what you are using. Usually, we only have limited icons, so that is okay.
Yeah.
So,
So for this one, just add this.
no, go to
Yes.
add parameter value. Yes. Yeah. So you have some problem. Can you go back to your Windows? Just type something. Your Windows, right? Okay, now it come up. You may suffer a little because it's going to be slow. Can you go to your window and open Notepad? Just Notepad. Yeah. You can type Notepad in the type search. Yeah, and then click on it. Right, and then just type anything, ABC, whatever. Yeah, and then Control A.
Yeah.
And then Control C. Copy them. When you're done, then go back. This problem might be solved. Now go back to a remote desktop. Yeah. Now, for example, you try to add, right? Try to add a variable in the parameter. You type something. Do you see the parameter on top? Go up. Oh, I mean, on the left, parameter. Do you see the word parameter? Yeah, type, yeah, delete it. Let's say type my variable. Yeah. Don't add space. Be careful, right? SWB is not a robust tool, so try not to use a special character or space, right? Let's say 1 and then space 0, right? And then say okay. Right. I think now it's better now, faster, right? So that's how you add the variable. Okay. Can you Control S, save it? Right? Can you double click the project one more time? I want to see if it's still so slow. Just double click the project name on the left. Yeah, double click, refresh the project. SOIIDVG. Yeah, this one. Double click. Now that is faster, right? Do you feel that? Yeah. So that is when you have this problem, go back to Windows and then just copy a text. Then it will be solved.
Yeah, and also I have version on this. Like I asked, but like when I delete.
Yes. Good.
I think before it couldn't delete, but now it's good.
Yeah. So very good. Yeah.
Yeah.
Great. Okay. So Shubhaka, okay?
Yeah.
Okay, good. Then let me continue. Right. So the most important is to understand that it does some pre-processing. Okay. So now let's go back to SDE. You may say, SDE, I don't have any variable. So there's no pre-processing. It still has, right? It just whatever comes in, whatever goes out. But actually, you need to be careful. You go to here, add the input, right click, go to add the input. And yeah, I have some problem, but that's okay. Right? I go to SDE. You will see, hey, why I have something called node, add node, right? I told you that add itself is a variable. So add node add, you may say, would that be a problem? I did not define something called node. So there's something called built-in variable in SWB. Node means that it's going to take the node number. For example, here is 1. It's going to substitute this one by 1. Okay? Can you double click this node? Right? Maybe I show you first. You see this PP file, right? PP means pre-processed, already pre-processed. You see this one become N1. Try to compare these two. Everything is the same, except that this becomes N1. And that is how you will do to make sure that, because you only have one master file, how can you make sure that they don't save the same file name? They will overwrite each other, right? So here, bring me to this. You have a command prompt here, right? Or you can go to extension command prompt. I click on this, it brings me this command prompt. What's so special? If I type PWB, you see that it brings me to the project directory. Every project in SDY, in SWB, is just a directory. It saves all the file here. I did the pre-processing, right? So it saved me a few files. You see it has N1, difficult to see for you, and dvs.cmd. It has pp10 because I have a 10 here. It has pp9 because I have a 9 here. So for each of these, it created a pre-processed file, and all of this can be submitted to run the simulation. Okay.
Okay, so what I'm understanding is the master file. There's one for each simulation program.
Yes, for each tool. Yeah.
It's like a generic code, and then the pre-processed file is where you take those user-defined parameters and substitute it.
Yes.
In the file, and that creates a pre-processed file.
Yes.
And so there's as many pre-processed files as there are experiments.
Yes, for each tool. For
Okay.
example, here, SDE, you only have one because there's no splits, right? You only generate one device, but then you have different biasing condition.
Okay.
Yeah, very good. Now, how about this? Let's try to run the project. But before that, I would like you to delete my variable because it generates too many files, too many splits, right? How do I delete? Just common sense, right click and then find, right? I right click, I see the delete, I say delete. Now the point is, I have different split. Now it is going to ask you, then, but which one you want to keep, right? Because once I delete my variable, 0 and 1 are the same, right? These two rows, the rest are the same. I need to remove one of them, right? So I say keep 0. This row will be kept, this row will be kept, right? So can you do this? Delete my variable and then kept and then keep 0. So when when you're done, now we can run the simulation. You see the run man here? just click on this. You say modify, you want to save it? Yes. Okay. Then you run it. Okay. And when you run it, you will see something that you are, okay, let's just wait. So it has different color. What yellow, look at the bottom right. Yellow means it is done. Blue means it is running. And then green means it's ready, but it's not running. Why is that? Because by default, we only allow you to run one job at a time. So you better wait. And then this pale green, it means that pending, because I cannot run before you finish, because it's trying to extract the data. Okay, while it is running, let's start navigate, right? This is SDE, right? Let's right click. And then visualize. And then visualize select file. It asks you, let you choose something to see. So I click on this n1_msh.tdr. And then open, right? Can you do this? And let me know when you are done, when you can open the structure.
Yeah, so before all of this, did you want us to do the pre-processing of the files first, or can we run it and
You
it'll
can, yeah, if you run it, actually it has option for you, say pre-process and then run. That is the default one.
Okay.
Yeah, you do need to pre-process.
So you said visualize and then.
Okay, so, say again. Well, I want to look at the result. I right click and then visualize, and then visualize. I mean, select file, right? You select it first. So you select n1_msh.tdr, and then you put in the new SVisual instance, and then open it. Say okay.
Yeah.
Then you get this, right? So before we, yeah.
Can we name, when it says nodes or scenario, can we name it anything?
Scenario?
Yeah, when you run the project, it has the first enter box. It says nodes/scenario, and it says
okay.
all.
You don't need to do anything. Usually, if you double click this one, and then you run, it will try to run all. So no need to do anything special. This
Okay,
one
so,
allow you to tell it which node to run, but let's don't do it now. Just
so
run all.
Are we visualizing the SOE first?
SDE, yeah.
Okay.
Yeah. So your screen resolution might be too large, making it difficult for you to read.
So how do we visualize again? We left click on the
right click, visualize Sentaurus Visual. And then choose the MSH.
Okay, one sec.
Now to the end, you can actually play with this already, even though we are still have not finished. Right. So the good thing, like in Professor Parent's lab and simulation, the biggest difference is that you need to be very careful. Don't make mistake when you go to the lab, because everything is money and the worst is safety. But here you can do anything. Even you crash it, it's not going to hurt anything, right? So be bold to do whatever you want to try. Click on any button you want, okay? So both of you opened the SVisual already?
Yeah.
Okay. Now, here shows what SVisual is about. It let you visualize the structure. It can be 2D, 3D, 1D, right? And it's very intuitive. On the left, you see material. Basically, you can turn on the material, click on the eye, it's all off. Click again, all on. I want to look at, I don't want to see polysilicon. Click on it, disappear, right? Toggle, come back. I also can say whether I want to see the field quantity. These are the doping concentration. I click on it, then it only displays the material. There's no field. Another thing is the mesh. This one is something very important and difficult in TCAD. In order to do simulation, you need really to give an appropriate mesh, because simulation is solving differential equation. You need to solve it only at this point. So meshing is very important. We will discuss a little bit, but not easy, right? And for you, when you start, I actually will give you some template to play with in order building from scratch. But however, I would like you to understand what they are, okay? So this is the material, right? You see, we have oxide, we have polysilicon, we have silicon, we have nitride, okay? If I turn them off, only turn on this something called contact. Contact is important. Contact is telling device that, hey, this is where I'm going to probe it. This is the source, this is the gate, this is the drain. And they are all in this pink color. But besides material, we also have region. For the same material, you can have different region. For example, our silicon epi, I turn it off now, is this one. It is silicon. And then at the bottom, I have our dot substrate. This is also silicon, but they have different region name. Why is useful? Because I can apply different physics to it. Okay, how do we call this? We call this by the programmer, right? I can quickly show you. For example, I compare to this structure, this what do you call this input file? You see that? I say I create a rectangle with this position. The material is silicon. The region name is R dot substrate. That's how you see R dot substrate here. This rectangle corresponds to this command. Okay. Now, if you go to line and particle, this is also very important, because sometimes some people give you a device, you want to make sure what are the contacts, or you want to make sure you do the right thing. You go down, you see this pink one, they are the contact. You see on the bottom, I have a pink line. If it's difficult to see, let me turn off everything, right? And then I come back to this line and particle. I turn on substrate, you see a pink line. Source is on the left, gate is on the top, drain is on the right, body tie is in the middle. Okay, so that is one thing that you can see from this structure editor. It gives you the dimension. The unit is micrometer, 1e minus 6 meter. Here show you the doping concentration. Well, difficult to see, right? I click on this legend, and then on the left, I have the legend properties. I click on this. I can change the font size. I make it 3 instead of 1. Right? Then it is easier to see. I click on it, I drag it. Okay. I think you're looking at me, right? So why don't you play with this? Do what I have done. Change the legend to larger font size, and then try to toggle to see if you're able to see different region. I give you 1 or 2 minutes. When you're done, let me know.
Okay.
Now, now I want to teach you a little bit more. One is this probe. This is very, very useful. This probe command, can you see this one? I can click in any places. It tells me what is the region name and also the material at where I click. And then also the field. For example, what is the X coordinate? What is Y coordinate? What is the phosphorus concentration? What is the boron concentration and dopant concentration? And by the way, in SVisual or in Sentaurus. By the way, this tooth, I don't know you know already, is by Synopsys, okay? Synopsys TCAD tooth, and it's called TCAD Sentaurus. The whole set of things, right? Positive means it is N-type. Negative means it's P-type. Okay, so if you have PN junction, the N-type will be positive doping, the P-type will be negative doping. But of course, there's no negative concentration. You're just saying that it is P-type. So this is useful. You click around. Sometimes you need this to help you to debug. Another is cut. You see, I have X, Y, Z. This is a 2D structure, so I only have X, Y. What does it mean? When I click on X, it means I can do a vertical cut perpendicular to X. So I move my cursor to here and click on cut. Then you cut this to me. So now I have two figures. Do you see that? I can magnify, enlarge it by on the top right, maximize, not this one, but this one. Then I can see this port only, right? And then I can just go around with this arrow. And here you show me what is the doping concentration. Now I click this maximize again. From the top to bottom, what are the quantities? Now, if you look at the bottom, you also see that whenever I've done something, it has a command. This is very useful. I will show you later. What we are going to do is you try to do something manually and then save it, and then you will redo it for you. Okay? Any question about this so far?
No, I think it makes sense.
But yeah, and of course you can do log scale here. These are not difficult, but I will show you more later. Okay, so let's quit, just close it. Now, so we created the structure and then it will do the simulation. The point is, how does it know which structure to simulate? Right? Yes, here, if I look at the command, you see that it say, save this as N1. Now, first of all, I'm going to type it. We have different devices, right? We have different devices, and I mean different tools. We have SDE, right? It has an input file, and usually it has an output structure. So there's a convention in TCAD Sentaurus. The input file, we all usually call it something underscore dvs.cmd. Okay, and then the output is actually ms.tdr. This is after mesh. Can you see it? We also have S process. The input usually is called fps.cmd. Okay. Maybe I'm not going to talk about the output. And then S device, or maybe we have output. Let me talk about output, right? The output is fps.tdr. S device, the input is des.cmd. And then the output is des.tdr or des.plt. I will explain more later. SVisual also can have their input file. It's called vis.cmd. Is this okay? So you see that although I call this N1, right? If you look at this, it says save the mesh file as N1. It actually becomes N1 msh.tdr. So this is the default. You just live with it. That's how it works. So, okay. So as device knows that it's going to take N1, but how come? How does it know? Well, if you look at the S device input file, okay, let's look at S device input file. It has a section called file, and then it says grid equal to something. Now, can you tell me what is the meaning of this at?
It's a variable, right?
Yes, it's variable, but we did not define here, right? It's a built-in variable. So this tooth is smart, SWB. When you see at TDR at, it knows that it's going to take the file from the tooth that is on its left, the nearest tooth that is on its left. So you check, okay, for N9, the nearest tooth is N1. So it's the output of N1. And because this is SDE, so by default, the output is N1 underscore MSH.TDR. So it's going to substitute this one by N1 underscore MSH.TDR. If I double click this node and look at the preprocessed file, do you see that it's substituted by N1 MSH.TDR? That's why it knows that I need to take this structure and do the electrical simulation. Might be still confusing to you, right? But later it will be very easy because all you need to do is just copy and paste the template. But I would like you to understand this. At this moment, you are going to do something simple. So this is straightforward. Okay. For example, let me do one more example. Let me just add a variable, dummy variable, right? I call it 0 and 1. When I add to here, then it means I have another split, right? 0 and 1. If I try to pre-process this file, I right-click it, I only pre-process this node, pre-process. I save it. Let me click on this node and look at the pre-processed file. Instead of N1, it is smart that it knows that the one in front of me is 26. So it put N26 MSH.TDR. Okay, any questions?
Okay.
Okay, good, right? So let's now, the S device. So let me show you again what it is about. We will go to next S device in detail on Wednesday. This is a pretty complicated setup. Remember, now I want to introduce another thing called hash. Hash has a special meaning to SWB. When you have a hash, then it followed by a keyword. Then it means that, for example, if hash set, it means it's going to set a variable VDD equal to 1.5. And later you can use it. For example, later when you see VDD here, not this one, sorry. This one, maybe not a good example. Oh, right here. So I don't want to do this because this example is not good, right? But just set a variable equal 1 to 5. Later you see VDD equal to substitute by 1.5. It also can have if else condition. If find that the VD, this at VD, what does it mean? It's a variable, right? You try to look at this VD. Well, VD is less than 0.1. So for this case, 0.05, 0.05, 0.05 is going to define the variable as this. Define this variable as this. So based on your VD, you can have different variable. And then you use the variable later. For example, here. For example, this transmon, if your VD is less than 0.5, is substituted by this one. If it's larger than 0.5, it's substituted by this one. That's it. Okay. So But what if this, can you guess? If you see a hash and then you see something that it doesn't understand, what does it mean to it? Is it an error or something?
I would think it's an error.
It's an error. But when you see hash and then something it doesn't understand, it treat it as a comment. It's going to ignore it and remove it before it's sent to the S device.
Wait, so if you use a hash and use an actual command that it can understand, it will treat it as a command.
Actual command for SWB, okay, not actual command for S device.
Oh,
yeah.
Okay.
Yeah.
So those are two different things.
Two different things. Yeah.
Above that, it's setting variables, and then below is the actual program for S device.
Right. So all these things are for SWB. Let's compare the preprocessed file one more time, right?
Okay.
Now you have raised a very good point. So let's imagine ourselves SWB. First, I see this 9. It doesn't have a hash and it doesn't understand. So you say, not my expertise. I just copy because S device probably know. Again, SWB doesn't understand this, it copy it. But then you see hash set, oh, excited, I know this, it means to set VDD equal 1.5. Then it's going to set VDD equal 1.5, but this one is ignored. It's not going to send to S device because S device doesn't understand. That's why you have nothing. And then you have the space, right? And then you come to here, you see, if VD equals something, okay, S device, SWB does all of this, but that has nothing to do with S device. However, you say that if VD is less than 0.1, I replace transmon by drift diffusion, right? So here, I have this transmon under physics. I just replace by drift diffusion.
Okay.
And then this file is sent to S device. And S device has its own language. When it see the star, it say, oh, this is just a comment. So S device is going to ignore this. It only will work on this. Okay, so these are the layer that we need to, very good, right? So actually, when I was Synopsys, I trained many people on this and many PhD, right? not even understand half as yours. So very good, you guys are very good. Okay, now, so with this, then it run the simulation. Let's take a look how it run, right? So let's right click. I want to show you SVisual, right? So can you open the PLT file this time? Can you do it now? Right click and open PLT.
So I can delete the previous visual, right? For SDB.
You can put in the previous visual or close the previous one and start a new one. Both okay.
Okay. So right now you want us to start S device?
Right click on S device, for example, Node 9, and then say visualize, and then SVisual select file.
Okay. Wait, can I share my screen?
Yeah.
Okay. So do you see it?
Yes.
So I don't have the node numbering.
Yeah.
I don't.
Oh, F9. Can you put F9? Press F9. Yeah.
Yeah. So
Now, since you're here, right? So you see 3, 4, 21 to 24, they are so-called virtual node. They actually has no simulation. They are there just because of the experimental tree. The one that really done the simulation are those yellow at the end, right? So you'll be 9 to 14.
Okay.
Yeah. So for example, can you right click on 9? 9, yeah, right click. Visualize, yeah.
This one?
Yeah.
Okay.
Yeah, and then okay. Why don't we just work on yours, right? Together,
Okay.
so that Tuyen, are you okay? Are you at this step?
Yeah.
Okay. Now, so you already done the simulation, right? And you save a file called .plt. Remember, I show you the output can be _des.tdr or des.plt, right? So now let's plot the IDVG. Okay, click on gate. Yeah.
Here.
Okay. Yeah. And then click on outer voltage, and then put 2 x-axis, right? We set the x-axis, and then I'll click on drain.
Drain.
Yes. And then total current.
Oh.
Right. And then to y-axis, left. Yeah, to left y-axis. You get the IDVG curve. Right? If you remember in I don't know, E122 class or whatever.
Yeah.
This is the IDVG, right? For example, what is the threshold voltage for this one approximately?
Right here, 0.5.
Very good. Yeah, 0.5, right? Of course, there are more than that, because if you try to click log Y, you click on log Y. On the right, sorry, on the right, all the way to the right, there's a icons, log Y. Yeah. Yes. Now you make the y-axis to log scale. Now you see that it's not really 0. It's subthreshold leakage, because this is a real device.
Yeah.
Okay. Okay. So that's how you do the inspection, right? But let's try to make it nice. How about you double click? You click on the Y scale. Just click on one log. Yeah. Click on them. Click. Yes. Then on the left lower, you see the something, right? Can you go to title and scale? Click on title and scale. Just type it. Instead of Y, can you type drain current? Okay. And then I'm not happy with the size. Can you make the font size larger? Title font? No, this is the scale font. Yeah. Let's say make it, what is it now? I cannot see it actually.
15. It says
even larger, like it 30, 30.
Oh.
We can type, yeah, and then apply. Okay, good. Right. I'm also want to make the scale larger. Can you change the scale font? Also make it 30. Okay. And I want to publish this paper. I don't want to use 1E. Can you use format scientific?
Okay.
Click on the prefer. Click on prefer. Yeah, scientific. Yeah. And this is something more publishable.
Yeah.
And then I don't like the color, right? Can you click on the curve? Just click on the curve. Yeah. Now go to the shape. Okay, first I want to make it really thick. Can you make it 10?
Oh.
Okay, any color will be okay. Yeah. Change it to 10.
The solid?
The solid, yeah. Okay. And then I want to see the marker. How about you turn on the marker? Right. And another marker, I want it to be a triangle and make it very large.
Okay. The triangle?
Mm-hmm. Do you have triangle? Maybe no triangle, then just use square and make it very large. Let's say 20. Right? And maybe this is something publishable.
Okay.
Okay. Now, the problem is you may spend 1 hour to make it nice, but then at the end you close it. And then later you find that you did something wrong. you spell the string wrong or whatever. You need to do it from scratch. This is not good, right? So however, as I told you at the bottom, the TCL command is save all the command that you have done. Can you go to save, click on save, and then just type any name, let's say test, T-E-S-T. Yeah, and then save. Okay, so Tuyen, are you here? Are you able to reach this step, save?
Yeah.
Okay, good. Now, let's just close it. I'm so confident that we are doing the right thing, right? I won't waste your effort. Close the whole screen.
This part?
Yep.
Okay.
Right, and I say, please redo what you have done, right? That would be terrible. So let's add a new S device after it. SVisual after S device. Can you right click S device? Remember, right click and then add, right? Add a new icon. Choose SVisual.
As visual?
Yeah. Yeah, if you cannot see it, then you use the pull down. That will be better. Just cancel. Use the pull down. Yeah. Yeah, you might need to change your resolution to smaller later. Yeah. And then just okay. Actually, okay, that is also okay. Now, the point is, now I want to redo what you have done. What can I do? I need to type all the command, right? But I don't want to do that. I'm going to import. So right click SVisual.
Where?
SVisual.
Oh, this one.
Yes. And then properties. And then you go to input files, and then click on the input, and then click on import at the bottom. Import, do you see import at the bottom? All the way to bottom? Yes, go up. Yeah. And then type test. Because you save it as test.tcl. Type, I think you need to type TCL also.
Oh, .tcl?
Yeah, .tcl. By default, it append with TCL. And then okay. Now, can you edit the master file of this new SVisual? The new one, the one you just added, not the old one.
This one?
Yeah, you just added this one, right? Add the input.
There's the edit and then.
Yeah, the master file. Right. So how do we make it larger?
I can.
On the bottom tab, what does it? Is this?
I mean, this zoom I think only makes this larger. But I can.
Okay, maybe you go to option. Go to the right top right. Yeah, click on this one and then option, something like no.
View.
Proofs. View. Okay.
I'll go to.
Okay. Anyway, I think maybe try to reduce the resolution of your screen. Maybe your screen was very large. The resolution later.
Yeah, I'll do that.
Okay. Yeah. So that is okay. But what I want to show you is that what you have done is that you have created a master file for it, right? You could have also copy and paste that file to here without import.
Yeah.
But you see what I mean? We use this click, and then now we generate the file that we want.
Yeah.
Okay. Now, can you close it?
So this is basically showing us what we did throughout that whole.
Yes.
It's like a log of our actions.
Yes.
Okay.
Can you run Note 25? Just click on 25, Note 25, and then run it.
Oh. Right here?
Yeah. The run man, yeah. Or you can, yeah, just okay. No need to choose anything. Do you see it did exactly what you did before?
Yeah.
Okay. Right. So Now, let's say you suddenly think that I don't want to use the red one. All you need to do, just go back to the script and change red to green.
Yeah.
Okay, can you close it?
Close this?
The whole window, yeah.
This, right?
Yeah. But now you still have one problem. If you try to run Node 30, you will get exactly the same result.
No, 30.
Yeah.
Okay.
Exactly the same. Although you don't remember, but I'm sure it's exactly the same. That is because when you do this manual clicking, you say you open the file. Can you close it? You open a certain file. So even now you are on different row, it keep opening the output from Node 9. It's not opening the output from Node 14. That is the problem. Okay.
Okay. I see.
Okay. Tuyen, have you reached here?
So I have problem to open the file I said.
Okay. Maybe I would like to work with you this time because your resolution is better. Yeah. Can you share your screen?
I'm working on a monitor, that's why.
Okay, yeah, sure. I mean, Tuyen, can you share your screen? Are you okay to share?
Yeah.
Yeah. So now, maybe you can maximize the window. Yeah. So, okay. Have you saved the script already?
I did.
You did. Okay. Now let's add a new SVisual after SDevice. So you want to click SDevice. This is SVisual. Yeah. It just cancel. Yeah. Right click. Yeah. Add a SVisual after it. And then add a tool. SVisual. Difficult to see. Let's use the pull down. Yeah. No, SVisual, not SDevice. The second last. Yeah. SVI, keep going down. Keep going down. Yeah, this one. And then okay. Yeah. Now we want to import the script, right? So you right click the SVisual, the new one.
This one.
Yeah, right click, choose properties, and then go to import input files, and then import, right? And then type the name .tcl. We always will append TCL. Take out TCL. Yeah. CL. Yeah, and then open. So do you remember what's the name you use?
So I just follow and save the same name.
You save as test.tcl.
I didn't put TCL, I just put test.
How about you just delete the TCL dot and see if do you have a, okay, and see if you can open. Does not exist. Can you scroll to the right to see if the score? You did the scoring bar here. Scroll all the way to the right to look at the T, right? Okay, yours is capital, that's why. And then open. Okay, and then okay. Okay, now, right? So let's run 37 just to make sure that it is there, and then we modify. Yes. Okay, yeah, that's good, right? So it's all there. Can you close it? So now we will do modification. Can you right click and edit the master file for this SVisual?
Which one?
Master file. So you need to click on the icon, right click, edit input. At the middle, no, not edit input. Yeah, commands. Right. So we are going to modify from here, right? So Shubhaka, are you ready?
Yeah.
Okay. Now you see what is the problem here? This master file always try to open N9. So even you are at N42, it's still open N9. That's not what we want. Okay. So what we want to do is just replace N9 by something called N at previous US previous at. So this is just like node, but it's going to put the previous node number, replace it by previous node number. Okay. So to do this, click on here. And then find and replace. Now you put N9 and then replace with at this one.
Yeah.
And then previous, Previous, and then at. So I actually made a mistake. Before here, remember to put N also.
And
Yeah, so that all the NI will be replaced by this, okay? Just click replace all. Right, and then close it. Now, do you see this? It becomes this, right? Why this is so important? Another things I usually will do is delete this absolute path. So that even you change the path, you change the project name, it will still work. Otherwise, you always try to look at the file in this directory. Okay, so can you delete this one?
of this?
Yeah. Yes. But do not leave this slash because it means the top. So you need to delete. Okay, good. And I told you can change the color easily, right? For example, what color we are using? I don't know where you put the color, but let's say, for example, I want to make this 9 only 1 instead of 10. Let's say after we try to publish a paper, we say, no, it's too thick. We need to change it to 1. Okay, now save it, Control S. Now, can you run 37 and 42 at the same time? What you can do is click on 37 and then Control and then click on 42. Yes, and then run. Yes. Very good. Just run. Now the problem is that you can only run one job at one time. That's why it's waiting for it to finish. Can you click on this, close it? This is something I need to, okay, not, okay. And then it run 42. Okay, can you close it?
Yeah.
So are you okay, Shubhaka?
Yeah, I'm just looking at the master file and finding and replacing.
Okay.
So you wanted us to replace N9 with N
What
at
is one?
previous
And
node.
previous. Yeah.
But is at previous a name that we came up with ourselves?
No, it is a built-in variable.
Okay, so previous, that's it, right?
Yes. Now,
And
for
then-
example, Juan, can you double click 37? and then look at the CMD file. And then go to, yeah, and then here, do you see here? Now, after pre-process, it becomes N9. Because the previous, before 37, is 9.
Okay. And the file that we modified, that was the TCL file, right? Or SVisual?
No, we modify is the master file for SVisual. It's not TCL. It's a CMD, yeah. So you don't worry about the name. You just right click and then edit and then command, input command.
Okay.
Okay. Now, so I want to show you now, what if you want to run many simulation at the same time? Can you close it? Let's go to edit and then preferences. Right. Now, if you go down, you see here local job. Yeah, expand it. Very good. Go down a little bit. Here you say maximum number of simultaneous job, right? Can you click on this and change it to 4? Yes. And then apply and save. And then close it, cancel. Yeah. Now, if you try to run them at the same time, can you click on them? Okay. You don't need to choose that. Next time you let it pre-process, because usually it doesn't take much time. Okay. Why there's only one? Can you move this screen to the right? Yeah, there are 2, right? Okay. You see they are not the same, right? Do you see that? Because this one is less than 1E12. This is more than 1E12. Okay. So that is how you do the scripting. So you will spend a lot of time to build something nice, and then you put it there. Even you get something wrong, for example, the thickness, we just change it to thinner. We just type it. If you have spelling, no problem. Okay. Any questions? So good. Yeah. Thanks for sharing, Tuan, and also Shubhaka. Okay. So let me share mine now. Okay, so you already done this, but then what about this SVisual? It's nothing but also just some script. But we are not going to go to too much details because you don't need it now, but you can use it, do this easily. It also start with some you can do it from GUI and then modify it. But here it has a lot of scripting. It also use some library, including it try to extract the VT, GM, etc. Now, but there is one thing I did not teach you that I actually need to teach you. I'm going to show you is that you see after extraction, it print out all these variables. This is very useful because I can have different gate length, different oxide thickness, and you tell me how the threshold voltage or GM are changing, right? I really want that. So how do I do that, right? So I think what I'm going to do now is to show you another thing. Now, just look at me. I'm going to add a new device. New tool SVisual, right? And again, I don't have the script, so I need to do it from scratch. For example, I need to open n9_des.plt, just like what you did already. I plot the gate voltage to the x-axis, the drain current to the y-axis, right? Now, there's a function you don't know. I've taught you probe. Remember probe in the 3D, in 2D? I can do it in curve also. I click on this, and then I can probe. Then you tell me when X is 1 volt, what is my drain current? So what I'm trying to do is that now I'm going to save it. S.TCL. Okay. So why I do that? Because I want to measure the drain current at 1 volt for all these curves. Right. So I right click again, property, import the script I just made. S.TCL. Okay. And then I'm going to edit the command. Right. First of all, as I said, I usually don't want this absolute path. And then I will replace everything, all the NI by N at previous. And this is done. Now, this is so-called, this file, the command, right, is called takehold TCL command. You can learn it by Google easily. But here is the probe command. It's trying to probe the curve 1 at X value. I did not click it right. Actually, I want to probe at 1 volt. So I will change it to 1. And then I set a variable called current. Now, you probably don't know this, but for the command in TCL, you put in this square bracket, it will just return the value of this action, and it becomes the current. And what I'm going to do is to type puts is another command to print it in the log file. DOE colon current, for example, I call this current $1 current, right? So this is a new language, right? I don't expect you to know it immediately, but you know what, approximately what I'm doing. When you need it, you just Google or ask me. So basically what this is doing is that it opened the file just like GUI, and I probe it, it returned the current value, and it becomes this variable $current. What I'm going to do is print a string. The string is going to be DOE colon, and then another string, any name, and then this variable. When SWB see you print something with DOE colon format in the log file, it's going to extract this and then put in the table. Okay, let me show you, and then you know what I'm talking about. Let me run 2 of them again. Just say run. It run. I close it. The other run, I close it. Do you see that I have a new column called current? One of them is 1.9 E minus 5, another is about 1 E minus 4. Why SWB know that? I double click on this one. Look at the log file. You see that? In the log file, I deliberately print DOE current 1 and then the extracted value. SWB see this, then it will put it here. So by doing this, I will be able to see how my different experiment has different quantity. And then I can export this to Excel spreadsheet to do some plotting that I want. Okay, I'm a little bit too fast. Any question about what I'm doing?
Not questions. I just I guess I just need to become more familiar with going through the files and writing commands and stuff.
Now there's another thing, right? You see, for this purpose, I don't want to see any figure, but it keep popping up. If I have 1,000 splits, then I need to close it 1,000 times, right? So I can actually right-click property. Instead of using interactive, I say batch mode. Okay, so you will just run the script. Nothing will pop up. Now I highlight all of them. And I just say run. And then we just wait. Right? I did not set the number, so that's why you do it one by one. But you see that it gradually populates the table here. Yeah. And with this, I can plot something, right? I can show my new device how it works.
Okay.
Okay, good. Now, then why do I do this? Now, if you come to this one, it's a sophisticated one. You don't need to understand, but it already has some built-in instruction. So why SWB know to plot this VTHGM? Because if you look at their log file, they print as DOE VTH number, DOE VHS number. So SWB will put 86.63 under S. That's what it is doing here, 86.63 under S. Is this okay?
Yeah.
Okay, thank you very much. Let's do a very quick practice, right? All we need to do is just actually, I have not told you how to add more experiment also. Just now, when I want to add a new split, I can add it from here. For example, I add it from, let's say, 0.01, a new VDD. Okay, but then it's added to everywhere. I don't like that. Okay, so I undo. That is dangerous. That is not robust. So I just say don't save. Right. So for example, I don't like this, then I might need to delete it. I highlight here and then right click and then say delete experiment. Right. Then this two row will be gone. But sometimes I don't want to do that. I can right click here and then just say add new experiment. And in this case, for example, I can add new VD equal to, let's say, 0.3. Then it only add one on here. Okay, it just add a new experiment, exactly the same, except we change VD to 0.3. Okay.
So did that add a new experiment or did it replace the existing one?
It add a new one.
After, right?
After, yes. It does not replace.
Okay.
Yeah, good. Okay. Now, so basically, I introduced the basics of SWB. In the future, if you're interested, you should actually take a look, right? I tell you how to change it. But the last thing I want to do is just create a project, right? And then advanced feature, you can take some time to take a look, right? So let's, how about this? Let's just create a project from scratch, okay? And then, so go to project. For this, let's do it together. Or one of you want to share? It's up to you.
I can share.
You want to share? Okay, then how about you share?
Can you guys see?
Yeah. Very high resolution.
Yeah.
Yeah.
I can actually
You might need to do this from even your Windows resolution. You need to reduce. I don't know when you try to work on this.
Yeah. Do you want me to hold up? I can see.
No, that's okay. That's okay. Yeah, no worry about this.
Is that better?
Oh yeah, it's much better.
One sec, let me.
Yeah, this is much better. And then now you can use Control minus to reduce the size.
Okay, one sec.
Oh, but just because you zoom in. Yeah, but that is still okay. Yeah, okay. Now let's create a new project from scratch.
Okay.
So yeah, good. New project, traditional project. Now, you be careful. If you look at the top, you see that it try to put your project in a temporary directory. So the first thing you want to do is save this project. Go to project, don't open, go to project. You are still in here. Save as. Go to save as, project. Oh, maybe you run into the same problem as 2N just now. Can you
Yeah.
go to Notepad and then do copy and paste? Just open a Notepad. You can type Notepad here. Yeah. And then just any word and then copy them. Control C. Yeah. And then hopefully you will be okay when you go back.
Right here.
Yeah. That doesn't look like it is doing.
If Hiu-Yung wants to share, she can also do it. I can follow along.
Yeah, sure.
Sure. Yeah. But why you're so slow? That's funny. You did copy, right?
I'm not sure. Huh?
You just now
Yeah, I
did
copied.
Control C, right?
Yeah, like
Okay. Maybe
I
you
can
need to
do
go
it.
back to full screen mode then.
Yeah, I can try that. But the resolution's
Oh, and another possibility is that it actually pop up a warning signal somewhere.
somewhere down here.
Yeah, I don't know. You go back to the full screen. Yeah, it's actually waiting for you to say something.
Oh.
Yeah, now go up. Go up. No. I mean, click this one.
Yeah.
What I mean is go to upper directory. Here, click this one. Yeah, and then just type a name here, slash, and then type a name, right? Slash, yeah, my project, for example. Yeah, and then okay. Good, right? So now you have created a project, okay? But your project is empty. So let's add a tool, SDE.
Okay.
Right click add, right? And then choose structure editor.
Structure, where is that?
Go up, SDE, here, SDE.
Oh.
Right, and then just okay. Okay, and then add another tool as device. And say okay. Yeah. So and then Control S to save it. Julian, are you okay?
I'm fully. So you said add device.
Yeah, SDE and then S device.
Yeah.
Okay, great. Now we are not going to do SVisual. Now you need to type in your own command, right? But of course now you cannot do that. But let's say someone already have it. Let's copy, right? So now go to this single device. Double click on single device. Right? Right click SDE. And then edit is, we want to see what is its input file, right? Commands. Right? Control O, Control A, and then Control C. Right? My goal is just copy this one, right? Now go back to your project.
My project.
Yes, double click. Now I want you to copy to its master file. Control V, and then save it.
And then can go out since it's saved.
Close it. Yeah, save it, close it. Now then, can you copy the same thing from the S device? You need to make sure you are in that because you are not there yet. Yeah, you need to double click so that.
Yeah, I gotta double click. Sorry.
Yeah. Right, Control V, good, save it, right? So let's run it first, right? Just run the project.
Okay.
Now, if it doesn't work, double click the project one more time. So reset the status. Yeah, double click.
Is it lagging or something? I don't know.
Okay, because it is waiting for your response. Okay. Now this is funny, right? You see, can you close it?
Yeah.
Now you actually a window pop up and you just
Yeah,
close it.
down here, I think.
Yeah. This one.
This one.
Yeah. Or no. Or nothing pop up.
That's weird.
Then
Close.
go back to the SWB. Yeah.
Should I do it again?
Hold on. So something pop up and then it got lost.
Okay.
Can you go to full screen mode?
You want me to connect it back to my monitor or whatever?
Yeah, so that we can see everything because this one is hidden somewhere.
Yeah.
You need to close it.
Yeah, it's way too small. So let me.
That's okay. That's okay, and then you connect back later. But we want to find that project, that folder. Can you minimize can you maximize it so we don't see your window?
Maximize this.
Full screen for the. I mean, yeah, here. Right, so this SDE got open. So I'm a little bit worried about your SDE tomorrow. Somehow you cannot see anything. Why the color is like that?
Should I maximize this?
No, we want to close it.
Okay.
Right, so Tuyen, I guess you have the same thing, right? But do you see any structure or all this noise like this?
Should I save?
No.
I will try to copy the SDY and SDE into the new project.
I can try it again if you want and see what happens.
Yeah, please try one more time to copy.
Okay.
And maybe you can go back to the large mode now.
Yeah. One second. So I can minimize this. Yeah, I don't think anything popped up.
No, you close already. As long as you don't run it, that is okay. Can you just go back to the original mode?
The SWB?
No, make the large mode. Yeah, SWB, and then the screen make it larger.
Yeah.
Don't connect to monitor.
Did I close SWB? I'm not sure.
You might be at the bottom. Can you go down?
Yeah.
Or maybe you close it. No, this is it. Okay, so why is that? That is because you have, can you right click the SDE? Properties, right? We want to make it in batch mode. Just now it was interactive. That's why it popped up.
Okay.
Okay, and then say okay. So Tuyen, are you okay to copy the S device?
Not yet.
Okay, can you show again?
Yeah, so go to
Single
this
device. Yeah.
device, double click, and when you, one sec. I double click.
Oh,
Yeah.
I think it's asking you to
The-
give a feedback. Input. Yeah, whether you want to say yes. Yes.
Yeah, so you go to,
single device.
Yes.
and then you right click on SDE. So right click here, go to edit input, and then commands, and that'll give you the master file. And then just Control A and Control C everything.
So is it open the single or
Yeah, so yeah, single
Because
device.
this show me and all
Yeah,
open?
go here, and then right click on this. And then click on edit input. And then go to commands. Did you get that?
Okay.
Can you make this larger so we see? We forgot to add the parameter file, right? So this is another thing. Thuyen, are you done? Have you reached this step?
Not yet.
Okay, wait a little bit. But you are copying, right?
Yeah, I'm not done.
Okay, let us know when you are there.
Okay. So basically we have
Right. So you see it has status 1 fail. Can you close it? Right. It failed at here. So I just explained to Shubhaka, right? This is because we have not give it the master file. So now can you go back, the parameter file. Can you go back to the single S device? Single, where's that?
This one?
No, the project from where we copy the. Yeah, single device here. Right, go here, double click. And then now right click the S device, add the input. Instead of command, not command, instead of command, choose parameter. Yeah, so this is the parameter file. Okay. Now it becomes very complicated. I think I should, it will be difficult to explain, but just copy all of them, copy. Yeah, and then go back to the your folder. Right, double click, and then edit the parameter file. Right click, edit input, parameter. Right, create empty file, and then OK. Now, so you see this is called sdevice.par. So this is also a master file. You can play with all the parameter through SWB by adding variable, okay? But now just copy and paste, just paste, Control V. Now here you will run into one problem because here you try to hash include, remember hash means that you try, is a command for SWB. Hash include, it means that it's going to include another file into this file. But we actually don't have this file in this directory. If we run it again, it will have problem. Okay, but just in order to make it work, so let's just delete this 9. Delete this 9. Okay, and save it. And now run it again, and it should work.
run all of them, right?
You can run all of them or only S device.
Okay, mine succeeded.
Okay, great. Now,
You want me to change it to interactive so we can see the graph thing?
not interactive because you mean to see the structure, the SDE? Yeah. Right. So no, we don't want to do it now. Especially we have a big trouble with your screen. Why it is displaying like this? We cannot see anything. But anyway, I want you to look at the structure first. Can you try to look at the structure we have created? How do you do that? Remember? Look at the output of the SDE.
Yeah.
You will right click, right? The node, the output, right click, yeah. And then you can do quick visualize, or the better is visualize. We only choose the last one, right? So here you only have this one. Remember how to maximize this screen? You click on this one, then it will maximize.
We visualize using Sentaurus Visual, right?
Yeah. Right. So this is the structure we have created.
Is it the MSH file?
Yes, MSH,
The TDA.
TDR. Yeah.
Is it it says N1 MSH TDR and then N1 half MSH.
Right. Only look at N1 underscore MSH.TDR.
Okay.
Okay, so this is the structure that we have created. By the way, I have not told you how to do the magnifying glass, right? You can use the magnifying glass here, right? And then draw a box to zoom in, zoom out. Yeah. Right. And then if you right click your mouse, hold the right button and you can pan around. Hold the right button. Okay. Right. And then zoom in. You can also do Control Z to undo. Right. And if you click this one, it will zoom out. Yeah. Now, our goal is this. I want to study how the current change when I change the channel length. Okay.
Okay.
Okay. So now let's open the input. So you are still running. Why it takes so long? Can you double click this one? Double click. Okay, maybe it was done, but it just was not updated. Okay, now let's edit the SDE master file. We want to edit the master file. We want to change the master file, not to add a new tool, right? So how do we edit the master file? You right click the tool, yeah, and then
Edit input.
edit input, yes. And then command. Right. So now if you go up, you see that, of course, you need to learn this command, right? But I will tell you, go to all the way to up, right? So it already defines some variable. So let's change the gate length, right? I want to have a variable on SWB, okay? So you change the whole thing to at LG at. Replace 0.05 by at LG at. Right, and then save it. Now, if you want to run this, you will run into problem, right? Because we need to add a variable to the SWB. Can you add a variable to SWB? How do you add a parameter variable to SWB, remember?
Yeah. SWB.
So what you can do is right click here, right? Right click. No, not here. You need to right click parameter. Yeah, not the icon, the parameter. Not here, the parameter in between. Not here, right? Maybe you can remove your mouse here. Right click here. Right, and right click, add parameter, and then type LG. Right, and then give some values. Right, it was 0.05, then why don't we try 0. You keep 0.05 and then add 0.1 and 0.2. Yeah, and then so okay. Right, so with this, I have 3 different experiments, right? I have one single master file, but I have different structure. Can you run all of them? Okay. So Shubhaka, are you okay?
Yeah, I'm just changing the parameter right now, changing 0.05 to @LG.
Okay. So we wait for you. When you're done, I would like to see together.
Okay, so I changed it to @LG and then I save it, right?
Yeah. And then you add a parameter in the
After
SWB.
for SDE, right?
Yes. By the way, this one, although it's under SDE, SDY can see it also. So SDY can take this variable also. You just need to add it before the tool that you use it.
Oh, okay.
Yeah. So I think to end, you can try to run this also while we are waiting. So when it's running, you can also double click here to see its status. Right? So you keep giving you the output. So let us know when you are done, Shubhaka.
Okay, yeah. Add a parameter called LG.
Yeah.
Okay. What do we click on again to add the parameter?
How to add? You click on here, right click.
1 sec. Oh yeah, right click.
Yeah, and then say add parameter.
Okay. Okay, called LG. And then are there any other things like list of values I should
Yeah,
include?
list of value, like what we are doing, 0.05, 0.1, 0.2.
Okay. Okay, so I did that. And do I run everything again now?
Yeah, run everything again.
Okay.
Time. Now
Yeah.
you have 3 of them, right? Can you highlight all? You can close this one. You can close the yeah, for SDE, can you not this 3? Yeah, this I want to look at SDE. Highlight all of them, and
These?
then right click, visualize, and then yeah, visualize from file. Now only choose the MSH, right? Use Control key. Only choose the MSH, not the half one, but only 3 of them. Yeah.
Oh, control.
Control, press the control and then click for the, yeah, and then say okay. Okay, so why do I want to do now? This is a but on the top, on the bottom left, right? It is very small, right? Because there's a but. What you need to do is just maximize and minimize one time.
Everything.
No, just click it one time, that will be okay. On the top right, where I circle. Click it, and then one more time. Click, not need to minimize. What I mean is, oh, then this one is gone. Maximize one more time.
Yeah.
Click on this, click one more time. Yeah. So somehow you minimize it and then it is gone. So you need to go to Windows.
Okay.
Right. Check the one that you already closed.
Oh, okay.
Okay. Yeah. Now you see you get different gate length, right? But sometimes we want to inspect at the same time. So try to highlight all of them. Control A. Not Control A. Or what's that? I think it's Control A. Can you type Control A? Yeah. And then link them. This is a link. Click on them. Okay. When they are linked, they have the same number. Okay. Now, try to zoom in one of them at the gate region. Try to zoom in.
Oh, right here.
Yeah. Zoom in. Do you see that? When you link them together, the action will apply to all of them at the same time. So this is very easy for comparison, and you clearly see that you have different channel length.
Yeah.
Okay, so I think you have learned the basics of SWB is good enough.
Yeah.
For today, I think I will just pause here. I think you're also tired. And tomorrow I will do SDE and then followed by SDYs on Wednesday. I think then we only need three days.
Okay,
But-
so
Mhm.
the whatever you said, the get started.